All right, good morning, guys, and welcome back to class again. All right, so the last video we actually talked about what we were looking at specifically in the last video was what's known as Ohm's Law. And Ohm's Law is just stating that potential is equal to current times resistance is all, which is this is one of the most used formula in all our studies of electricity for that matter. So I've got other videos where I spend a lot of time breaking down what series and parallel circuits are. Here's two definitions. This video, all I'm going to do is work two of the most basic, easy examples of series and parallel circuits. Again, I've got at least 5 other videos on my channel where I'm talking about series and parallel. Watch them for the harder and for more in-depth explanations on everything. So I'm kind of jumping right to it, and let's just solve some problems. Essentially, the first goal you should try and have for every... Wow, look at all that random marking on my... That's a good way to start the video off. Essentially, what should happen is the first thing you should try and do when solving these problems is, I always tell people, find your R total first. So find the total resistance. Some books will say find your equivalent resistance. It doesn't matter. I just like saying total. Find your total resistance first. And to do that, you identify is this a series or parallel circuit? Well, obviously, I'm telling you it's series here, but it's series because there's only one path for the current to flow. Remember, these V1 and V2, that represents voltmeters. Voltmeters have huge internal resistances, so there's no current going to these voltmeters. So the current only has one path in the circuit, and that's what defines a series. So to find your R total for a series circuit, all you have to do is add together the resistance. If you had 10 resistors, you'd add all 10 together. So in this case, R total is equal to 5 plus 3 for a total of 8 ohms of resistance. All right, so that's like our first priority. Second priority in solving these problems should always be to try and find like your total current. So in other words, what's the current leaving the battery, if you will? So what is the actual current leaving the battery in this problem? That's a very important thing to know whenever you're solving these problems, even if it's a huge problem. That's important for you to know. Well, a little while ago we talked about Ohm's Law, V equals IR, and that's exactly it. The only formula we need to solve the rest of this problem is Ohm's Law. So V is equal to IR. So if my goal is to find the total current, I need to know the total resistance and the total voltage. Well, the total voltage is your battery that's in the problem. So in this case, I've got a 12-volt battery, and that's equal to I times resistance total, which is 8. So we've got 12 divided by 8. Well, let's see what we can't do with 12 divided by 8. I think we could probably handle that without the calculator. Wow, it's 3/2 or 1.5. So we've got 1.5 amp. By the way, one of the things I'm doing with these examples is I'm keeping the numbers very easy. Usually these resistors are like big in the thousands and hundreds of thousands even sometimes. For the sake of learning to do this, I'm keeping the numbers small so it lets us, have a little bit more manageable time solving these problems. Now, this problem could ask us to find the current in each resistor. One of the foundations of a series circuit is this. We just found that 1.5 amps of electricity leaves the battery. We'll follow that. It's like water in a pipe is the best way to explain it. That means there's 1.5 amps of current flowing through resistor number 1, and there's also 1.5 amps of current flowing through resistor 2. And then like maybe I've seen problems where they'd like make that point D, and it'd say what's the current at point D, and of course in this case a series you'd say it's still 1.5 amps. Because remember, we talked about that these voltmeters have a huge resistance. It's massive. I'm just going to write a little infinity symbol there. They have a huge resistance, so there is no current going through this voltmeter that's being mentioned. So now then the question would be this: can you find the voltage across resistor 1? Well, the only formula after we find our total resistance is Ohm's law for the entire problem. So what's the current going through that resistor? Oh, well, it's 1.5 amps. What's the resistance of that resistor? Oh, well, just so happens that's 5 ohms. So what's 1.5 times 5? Well, that would be 7.5 volts. Now, you should have some intuition before we even solve for voltage number 2. Well, again, what is the current through volt resistor number 2? Oh, well, that's kind of easy. It's 1.5 amps. It's the same throughout the series. What is the resistance in the second one? Well, it's a 3 ohm resistor. Wait a minute. 3 times 1.5 is 4.5 volts. Wait a minute. What is, look at V1 and V2, and what do you notice? Oh wait, it's 12 volts, which just so happens that when I'm looking at this problem, the battery was a 12-volt battery. So it should make sense to you. Also, what should make sense is it took more potential, it took more voltage, more push to shove these electrons through the 5 ohm resistor than it does the 3 ohm resistor. So that should kind of hopefully make sense to you. So what about how do we work a basic parallel circuit? So a basic parallel circuit looks like this, and it gives you this ability for the current to split within the problem. So I want you to kind of follow the current. The current is going to leave this battery, hanger right, and you notice something that I1, so a lot of times people call this I1, but it's the same thing as I total because you're referencing the current that's leaving the battery. And you notice we call this a junction. What happens? The current splits into 2 other currents. All right, so here's what I want you to do. Find the resistance total. Step number 1, I told you, is always find your total resistance. Well, to find total resistance for parallel, it's a little bit different. The equation, instead of just adding them up, and again, I've got other videos where we go into this in so much more detail. You can just add up the fractions of the resistance. Now, there is a little like cheater equation. There is another equation for parallels. I don't think I said in any of the other videos. That looks like this: the product divided by the sum of the 2 resistors. Now, what's cool is that formula will work to let you find the resistance, but there's one little caveat to it. This only works for a 2 resistor problem. That's it. That's the reason why you don't see me using that one, although it makes things easy. Like, for example, the problem we're working now, it would be 200 divided by 30 for an answer. The reason why I don't like doing this is this 1 over R type equation. We can keep, even if you had an R3 and an R5, you can just keep adding those together. So I'm going to do it like this. I'm going to use the 1 over equation so that you could have more resistors. 1 over 10 plus 1 over 20. And again, you could just keep going if you wanted to. All right, so this is 1 over R total. Let's see if we can't do this in our heads. That would be 3 over 20. Now, here's the deal. Some people will then call this their answer. This is not your answer. You have solved for 1 over R total. Matter of fact, you don't even have an ohms for an answer. If you look, your unit right now is 1 over ohm. So you need to take a reciprocal in order to finish this problem. That's what students always forget, is to take the reciprocal. So R total is actually equal to 20 divided by 3 ohms. I'm going to get that to a decimal just for the sake of making our math a little easier. 20 divided by 3 equals 6.66666. So 6.67 ohms. If you did this in your calculator, there's also a reciprocal button in there you could use. Hopefully you know. Say, for example, in your calculator, like maybe you just, here, let's try and do this. 1 over 10. Go over. I do love these Casio calculators. If you've watched any of the videos for like 10 years, I've been using these Casio calculators. Your reciprocal button on your calculator is that x equals -1. Maybe if you got a really old calculator, it says 1 over x. But it just says -1, and wow. And it's 6.666. Anyway, you got the idea. All right, so remind me now. What was the next thing? After you find your R total, the next thing was second priority, find I total. Well, remember, the only thing we're going to use is V equals IR for the rest of the problem. So we know that the total potential is 12 again. We know that the resistance is 6.67 or 666. So now all we have to do is 12 divided by 6.67. Oops, got a little error in there. And we know that the current is 1.8 amps. So we've got 1.8 amps of current. Now check it out. That's 1.8 amps leaving the battery is 1.8 amps. So what's going to happen, kind of erase some of that. Wish I had a bigger diagram now. What's going to happen to that 1.8 amps? So that means that's my I total, and that is also my I1 in this diagram I've been given. But what's going to happen to that 1.8 amps when it gets to this junction? Well, it's going to split. You should be able to guess. It's like two clogged pipes. Which direction more current should flow? Well, there should be more flowing through the 10 than the 20. So once again, the only formula we need to solve this problem, we could do this one by ratios, but I want to give you a way of doing it for any problem. Say you want to find I2. What's the only formula we're going to use for the rest of the problem? V equals I2R. So what's cool is in parallel, potential stays the same. So for a parallel circuit, essentially, remember, this battery is literally pushing the electrons. Now, always think of it like somebody bench pressing. They're pushing both sides of the bar the same. They're pushing the 10 ohm resistor and the 20 ohm resistor. Both have got the same potential pushing across them. And that's one of your properties. And again, I have other videos where I go into huge amounts of depth on this. So I know that the potential across I2 is 12 volts. I2 times 10 ohms of resistance. Divide that, you get 1.2 amps in I2. Well, let's say you want I3. So V is equal to, this time, I3R. Remember, all we're going to use is Ohm's law to work the rest of this problem. Well, and you should already have like a little guess as to what this answer should be. Take a look. We know, we already found out that leaving the battery, here, let me draw this a little bigger real quick. We already found that leaving the battery was what? So here is our basic diagram. And then up over, there's a resistor up there. There's a resistor down here. They come back together and back to the battery with a little wavy line in the middle, apparently. Here's what we've already discovered in solving this problem. Even before you do your math, we found leaving the battery is 1.8 amps. We've already found that going through this 10 ohm resistor, there was 1.2 amps. So at this point, you should have a pretty good idea of how much current, referred to as I3 in this example, How much current is going through? Well, if there's 1.8 amps of flow coming in, 1.2 amps going through this direction, then obviously there can only be 0.6 amps going through the bottom. Also, look at the numbers. The 20 ohm resistor has twice the resistance of the 10 ohm resistor. So if it's got twice the resistance, it's got 1/2 of the current flowing through it. So anyway, this was by no means meant to be like a comprehensive parallel and series video. If you want to like go into huge details and explanations, I've got other videos that go into far more detail. So anyway, all right. Well, good morning. Hopefully this gets you working some basic problems, and we'll talk to you later. Bye.